Okay, this video is about program number 3 from tutorial 1. We will be doing the same program, which is showing circles moving on the screen, but this time we are going to use the object-oriented approach. Okay, in program 2, I showed you a struct. Okay, a struct basically is the basis for a concept in object-oriented programming, which is encapsulation. Okay, in struct you bundle a list of variables into a single struct. Okay, just now we call it circle. So in object-oriented programming, it serves the same purpose, but it it goes beyond that, whereby besides putting together the data, we can also add functions to the struct, or in proper term we call it to class. So I have provided here the template for program number 3, and then I put side by side program number 2 so that we can look at comparison. So basically what we are going to achieve for circle, we bundle data as well as the action. Okay, the action, which is just now for procedural programming, that data is one part, and then you define the action separately, like draw circle, undraw circle. Okay, now so I think it's a good idea to introduce you here we are going to encapsulation. We are going to implement two concepts here: encapsulations and data hiding. Okay. Last time in my last lecture, I was giving this lecture about some principles in object-oriented programming. Okay. In this program, we are going to implement these two concepts. Okay, encapsulation. Okay, encapsulation, we package, which is to package or to combine data and operation all together in the same entity. We call it class. Okay. Data hiding is basically the concept in object oriented, whereby the data or attributes should be hidden. Okay, that means here you cannot access the data from the outside. Let me show you what I mean by this. Okay, if we take a look at the struct, okay, we know that C1 is a kind of class, okay, a struct, and then it has X, right? This is what we call X is not hidden, because currently we are working on main. From main, and then from this object we can access directly to X. Okay, so because that's how struct behaves. Struct by default, it is a public, so that means it allows the outsider, which is something like this in main function, it allows to access the attributes for struct. Okay, however, in object-oriented programming, it is best practice to make sure your data always hidden. Okay, so that's why in C++, by default, your data, okay, by the way, let me recall this term. Inside a class consists of members, whereby members, it has two types. One is data, the other member is operation, or we call it methods, or data we call it attributes. Okay, by default, members inside a class are private, okay, because it enforces this concept of data hiding. So if you don't specify, let's say you don't, if I write something like this, now this is a class, but it behaves similar to struct, because struct, all the attributes are public. So that's what this code or this class definition represent. So it becomes like a struct. But this is not the one that we want to achieve in object-oriented programming, because in object-oriented programming, okay, this is very important. You always want to implement the concept of data hiding. You must make sure the data are always hidden. So you can do it by simply putting something like this. Okay, now it becomes hidden. Okay, that means later on you cannot use something like c1.x. Okay, or if you want to be more explicit, you actually can write here, as you may guess, private. Okay, make it hidden. Okay. There are basically three types: private, public, and protected. Okay, but it's beyond our discussion in this program. Okay, so we make it as private. Okay, all the data is private. Okay, the only things that you want to make public, okay, why you make it public is basically to allow that member to be accessed from outside. So normally you put your attribute, your functions, oh sorry, it's not your attribute, but your operations, your function or your method to be public, because that one will be used by the outsider. So like something like this. Okay, if you want to draw, then you need to make sure like draw circle here. The draw must be public, so that you can call draw from the outside, from the main. So, or when I talk about outside, basically outside from the class. Okay, so let us complete this. Okay, okay, here, uh unlike, okay, unlike struct, because struct you can only only have data, right? You don't add function inside. Okay, unlike the struct, you can have function inside circle. So how you do it? You write it here. Okay, so for example, just now we have draw, right? So I can okay, I can bring this draw. Okay, so this is, okay, you write, okay, I'm okay, actually this is draw circle. Okay, you can also actually write draw circle, but it's not that meaningful, because we are currently inside a circle. So that means when we talk about draw, that means we are talking about drawing a circle. So it's a convention to write this in this way. Just write the operation. You don't have to specify something like the one we do it in procedural programming, because in procedural programming you might be drawing a circle, or you might be drawing a rectangle. So you need to explicitly mention the what kind of drawing this function is doing. So here, because we are dealing with circle, we are putting this draw inside circle. So it makes sense that, oh, the draw here is basically draw circle. And then in order to draw max its job, it needs information, right? Okay, because we want to draw a circle, we know that we want to draw a circle. So what is the information about the circle? So like the one we do it here, we need color, we need the radius, and so on. So in procedural programming, you keep using parameter passing, because the data comes from the outside, from the main. But in this case, for object oriented, this is actually one of the main advantage of object-oriented programming. You make the object to be self-contained. Okay, which is the object itself. An object is self-contained entity. Everything is there. You don't have to use parameter passing here. That means I don't need to pass like something like x, integer y, and so on. Why is that? Because x, y are already inside the class, inside the object. Okay, so in this case, we no longer need parameter passing. We can simply do the actual pass. I think let's make this more explicit, make it radius and color. Okay, so set color with color. Okay, and circle with circle x, y, and radius. Okay, so again for the undraw, void undraw. Again, I'm not using undraw circle because you know we are inside a circle. So again, I can do it same as this, but again, if we do it something like that, this is a wet code. Yeah, we have this. So we can actually simply write the way we did in program 2, whereby introducing a temporary variable. So I can, let's say I can hold the variable first. So something like integer, I hold the current color, hold color, okay, which is the current color of this object, and then I change the color to let's say black, and then I draw. Okay, once I draw, then I change back the color to the color we held just now. Okay, why we do in that way? Because we simply want to reuse the draw. Okay, but of course this one is not a good as you can see, it introduced more code basically. So we can refactor this. I will show you how to refactor this. Okay, let me do it something like this. Void, I put draw, I draw helper. This is just for helper. Okay, normally when you write code, most of the time you keep introducing convenient code. Okay, in this case convenient method. Okay, actually to assist the this part. Okay, because this is actually we are trying to reduce code duplication, but we introduce more lines here. So let's take a look how okay, so I introduce a helper for the drawing, draw helper. So if I want to make it more explicit, I can simply do it something like this. Okay, just to differentiate between the draw here. What I can actually use draw helper and so on. And what we are going to do here is that taking this here, we are going to use parameter passing. Okay, just it's just, but since we okay, because later on we want to draw, call the draw here, and then we already have x. Okay. The only difference later on between draw and undraw is only the color. So that means this color, okay, I can use underscore color here. So I put integer underscore color. This color can be passed as parameter later. Okay, last time I mentioned we don't need we don't need a parameter passing when we work in a class, right? Because but you need to recall what is the purpose of parameter passing. Okay, besides passing data, it can also be used for generalizing the code. Okay, so what I was trying to do just now is basically I try to refactor the code so that the draw can be used by draw and also can be used by the undraw. If you use the draw, the underscore draw inside here, you can draw with color supplied by the object color. But for the undraw, we want to draw by always using black color. Okay, so I hope you see my point here. So this is we do it the color here. This is actually a technique how to do a refactor, to do refactoring for, okay, again, refactoring normally you want to do it for reduce code duplication. Okay, color and then color here, right? So the same is, the rest is the same. Okay, x and y radius are basically attributes. That means here, right? But for the color, for this case, undraw, the underscore undraw for the color, actually a parameter. Okay, why parameter? Because we want to make this function or the underscore draw to be more generic, so that it can be used by the draw here and also the undraw here. Okay, let's consume this code. Okay, so how should I do that? As you can see here, the draw only needs color. So where should I get the color? The color is inside color. Okay, where does color come from? From this one. Okay, it passed here. Now how about the undraw color? How about this one? We can simply use the helper undraw, but always black. See, hopefully you see my point here, how we do this kind of refactoring just to reduce the code duplication. So it will be doing the same what we did in here basically, but this is actually a better way, because we don't introduce an extra variable like the one just now. We need to introduce extra variable. That means in behind the scene you use memory and so on. Okay, so this is a better way. Okay, so we have draw, we have the undraw. Okay, and then what else we need? Okay, let's try to plug in I think the code, the remaining code. Okay, just now what I introduced to you is about the concept of data hiding and also the concept of encapsulation with the with adding uh, the functions altogether with the data. Okay, now what we did so far is basically just definition. Okay, when we're working on definition, normally we just provide or we just specify how things should work. Like in this case, how the drawing should be done. Okay, we are not dealing yet with the actual drawing. When it comes to actual drawing, you need to provide actual data. So where the data comes from? Okay, as you can see from our previous code, the actual data still comes from the main. Okay, so you need to specify, you need to provide a way how to pass the data, okay, from main to the object. Okay, so the way we do it in object-oriented programming is from a special method. We call it constructor. Okay? Constructor is a special method, which is the idea of constructor, as the name implies, to construct an object. So the purpose of constructor is actually to provide a way for the object to be initialized to get the data. So How do we know it is a constructor? Because a constructor is just a general, is a kind of function, or is a kind of method like draw and draw. But in C++, the way we treat a constructor is by having the constructor or the function name to be the same as the class name. So something like this, circle. Okay, this is a class, and then when you make it with parentheses, it becomes a function, and then when you put inside a class, it's a method. This is a special method because it has the same name as the function name. So it is a constructor. We call it constructor. And the purpose of a constructor is only to allow or to provide a way or a mechanism for the object get the initial data, get the data. Okay. So again, we are not going to do any manipulation. I mean, any like for you don't show circle here, you don't move circle here. Constructor serves only for provide the data. Okay, because in object oriented you start with object, but if you don't have objects, you cannot execute your operation. The object is only created uh, from a constructor. Okay, how do we deal with this? Okay, so again, constructor is to provide a way to supply data to the object, okay, from outside. So last time I talked about most of the time you don't need parameter passing in object oriented programming, right? But there are cases that you must use parameter passing, although you are in object oriented programming. Okay, this is the case because you need to talk with the outside. Okay, because the data comes from the main. Okay, so the way we do it actually something like this. Okay, we simply okay, we simply, okay, I will call this like x, let me call it xx integer, yy integer, r integer, color. Why I write in this way? Okay, basically I want to differentiate from this, try to use different. So I think for radius I can simply use r because it is different from radius, and color. Okay, now, okay, attributes versus parameters. Okay, hopefully you familiar with this term because I keep seeing student got confused regarding this term. Okay, maybe they understand the term, but the way they do using it is looks like they got confused. Okay, so what we want to do here, actually we want to supply data, right? So who will supply the data? Data supplied via parameters. And then who will get the data? So parameters, okay, to supply data. Okay, you use it as for the purpose of supplying data. Where is the parameters? This one, the one you put inside the parentheses. Okay, all these are parameters. So that's why I purposely use different name. Of course, I can also use XX here, YY. But for this video, I'm not going to show you the solution for that. But let's make it different so that you know that these are parameters. Which parameters? Which is which? Okay. So these are parameters. Okay. So XX is parameters. And then attributes is to be the one that to be initialized, to be set. Okay, it is the objects attribute. Okay, so attribute, these are the attributes. Okay, so that means you supply data from outside via the parameters, and then that one will be set to the attributes. So this is what I mean. So that means x you supply, and then you set to x, because x is the one that you want to set, and then you get the value from xx. Because I keep saying sometimes you write something like this. This is in there is no error regarding syntax, but the meaning is different. Okay, here you are setting the parameter using the attribute. It's supposed to be variable. So that's why if I write something like this, okay, xx, it should also compile, but it is not correct, because what we did here, basically you are setting parameters with parameters, meaning that you are doing the same thing here. Let's say you are giving with 10, so x always 10. What we want to achieve, actually, we want to set these attributes. So I purposely change this to x, so that xx is the data we get from parameter, and then you set to the attribute. Okay, now we can continue this to the rest. Then this is yy, and then radius is supposed to be r, and then the, what is it? This is a color with c. Okay, as you can, normally this is the operation you all most likely be doing all of the time regarding regarding the constructor. You just need to this to do this, to supply data to the object. You don't do any fancy thing here. You don't do like create do the actual operation like moving the objects or displaying objects and displaying circles here. The reason for constructor is there is actually for that memory management. Okay, here we are talking about specifying the content of the memory. Okay, that's it. Now once we have that, now we can start consume this. Okay, we are trying to do this the same. Okay, I'm going to use this. Okay, so how we do it in object oriented, this is the one we familiar in struct. So this is okay, we are going to do the same. Okay, but here we are going into in the in object oriented syntax. So we okay, we declare here, this is declaration, right? Okay, this is declaration. Then basically what happened, okay, this is a special treatment for object oriented. Okay, whenever we create an object, it is always execute a constructor. So if you don't specify a constructor, there is a special constructor will be executed by default, but I'm not going to talk that here. We are going to look at that concept later about the default constructor. So here I want to be more explicit. I want to explicit, okay, which constructor I want to access, but since here we only have one constructor, this one, right? So I simply use this one. So how you do it, how you call to this constructor, create an object and specify the parameters. Okay, like this one, you just create an object, I call it c1, and then we put parentheses. Okay, you don't get confused, it looks like a function call here. Basically this is actually c1 is not a function, c1 is an object, but we explicitly Actually this one is implicit call to the constructor. We don't see, uh, you can actually also do it something like this. Okay, I think this one might be you are familiar with. And then we provide, let's say, what is the value we want to achieve here just now. Okay, we have 200. Okay, 200 for x, y is 500. Okay, and then 200 for the radius and color, this one. Okay, I can write something like this. Is familiar, right? You are calling to the constructor explicitly, but actually this one is, it is the same meaning. Yeah, quote unquote, it's the same meaning. Okay, something like this. Okay, you uh this is actually the one, the way we write in C++. In other language, it's slightly different. Okay, like in, I think in JavaScript and Java and Dart is slightly different. Okay, I can proceed with the rest for C2. Okay, just for simplicity, I can simply copy this one. Okay, this is actually the case I mentioned before, where you need to use parameter passing, because you are specifying the actual data, okay, from main. So main is basically the outsider from the outsider from the class. And again here, as you can see here, we plug in straight away the data here. We don't let main to hold the data for each individual object. What main holds is basically are the object itself, but the data about the radius, center, color, and so on are held by the object itself. Okay, so C1, C2 are inside main because we declare inside main. However, for like this one just now, I think in our example program 1, we need to declare x1, x2, all of them are held by main. Okay, but here the information about each circles are held by the circle itself. Okay, so that's the beauty of object-oriented self-contained object. Okay, but still the object is inside main. Now, then how to display that? I think we are how to display. This is we are going to achieve the same way here. Okay, if you look at the procedural programming, the grammar likes you start with verb and followed by the subject. Okay, so in object-oriented programming, because object is first-class citizen, you start with object. So our object is C1 followed by the verb. Draw, something like that. See? So this is the beauty of object-oriented. You don't, okay, since you already configured the object, you specify the data that they should have here in the constructor. When you start do the manipulation, now you can see here you no longer need to use parameter passing. Okay, it's supposed to be something like you as you can see, we start with object. If you look at the grammar here, you start with object, which is the subject itself. Okay, subject, and then followed by the verb. Okay, it's different from procedure, because procedure you start with the process, which is the action or verb. Okay, yes, that's how you look at the syntax from from the syntax perspective. Okay, now then we can actually keep utilizing this. Okay, I will copy this. Just copy this. Okay. How to Android, again the same. Android p1 dot andro c2 andro. Okay. Now we come to this. Let me just copy everything first. Okay, I have change or refactor the code such that they becomes OOP. Okay, but okay, now we have problem with this. Okay, I think let me save this first. Okay, okay, when we okay, so we finish with program number 2. I can get rid of this program 2 from the screen so that we can have larger space here. So when I started to to run, let's try to compile this. Okay, we supposed to be getting error here. This is expected basically, because why? As you can see here from the error lens extension, uh, circle X is private. Okay, this is actually one of the major concept in object-oriented that you're supposed to be implementing. You want to make sure the data to be always hidden, but it gives us these issues. Okay, if you are not familiar or you are just getting started with OOP, this is quite annoying actually. Okay, quite annoying. So but you need to bear with it. Okay, because that's how OOP works. Okay, you must make sure your data is hidden. So you might be tempting to to replace this with public. It's supposed to be working, but if you make it public, it's supposed to be solving the problem. Okay, Uh, but that's not how you solve it, because you violate the principle of data hiding. So how to do that? Okay, how to deal with this kind of situation? So as you can see here, the data hiding, only the data supposed to be hidden, but you you can do the same job here by changing this into method. Okay, what actually we are doing here? Okay, let's try to write something. What actually our intention here, the goal of this line? This is basically we want to move by here by 50, right? Okay, this is the same to move by -1. So we can generalize this action by calling it move. Okay, just now we have draw, undraw. Then basically in object oriented, that's how you work on OOP. You keep adding attributes, you keep adding method as you see fit. So for example, just now I need to move my circle. So I cannot do it by using calling directly from main. So I'm going to introduce a method. I'm going to call it move. Okay, so again here I can simply write move without parameter. So I can write something like move left. If move left, what I did here, actually I just bring this part. I just bring this part to here. Okay, So now since we are currently inside the class, actually we are referring to X, right? Okay, this is not move left, but move right. So plus 50. Okay, that's it. So if you notice here, when we do the movement, of course you need to move, and then you also want to show the result on the screen, right? So this is actually the beauty of using modular. You do one task for each module. In this case, one task for each method. So I don't mix my output, which is for drawing and drawing, at the same place with the move. Although the move actually also has relation to drawing. So what I did here, I just change the variable, but the actual showing will be done by the draw, so we don't have to worry about it. Okay, I can also introduce, as you may guess, move left. Okay, move left, and then this is minus 50. Okay, so I can refactor this. Okay, as you can see, the pattern is the same. The only difference is one, right? And then it is always by 50. Then what if you want to change the speed? So for example, increasing to 100. So this is no longer valid for that, because we don't specify the way of changing the value. So that's where you want to use parameter here. Okay, again, parameter is used here is for making it more generic. So move. So instead of using right or left, I can put like dx. Okay, and the dx is x equal to x plus dx, or you can simply use the shorthand. It is the same, right? So if I want to do it for the move left or move right, okay, let's consume this in the code. Okay, here, this one. Now I can use it, which is the object. Again, when we deal with object oriented, we start with object, and then I can invoke move. To move, here I plus 50. Okay, for C2, move to the left, minus 50. So you see, it is more generic. So you can use the same function to serve for different direction here. Okay, so I think we pretty much done here. Okay, I think we need to get rid of this again, and then I think that's it. So let me compile this first.